Hi, today we're looking at the average rate of change. So how much does the graph change over a given period? That's actually what it means. Or it actually is exactly the same as a slope. We look at what the slope is between 2 points, even though the function might not be linear. If you see our graph on the left side, it's a quadratic function, 1/4 x squared plus 2x. And we're going to look at the interval -4 to -1. And the interval gives us two x values. And these two x values are the points that we're going to look at. So we're going to look at, if you look here in a graph, -4 and -1. And we're not just looking at every point in between, we're just looking at the start and the end of our interval. So we're just looking at -1 and -4 and -1. And we're doing this with, and we're calling this the average rate of change because we're changing in a, it's changing in a function that's not linear. The average rate of change is calculated by the change in y over the change in x. And what it actually means, it is actually exactly the same as we do in slope. For slopes of linear function, we do this exactly the same. If we're going to calculate it for this, we already know our x values because our x values are the given interval, -4 to -1. But right now we're looking at also a y value, so we need to find the y values of these 2 points. So what we're going to do is we're just going to plug them into the equation, and here's what we get. So we get 1/4 and then -4 squared, which is 16, and 2 times -4 is -8. So this calculates out to -4. That means that our y value, if x is -4, y is -4. And you see that in our graph here at that point. Then if we go to x is equal to -1, we do the same thing, just calculate what it will be, and we'll get a -1/3/4. Or as you can say, it's -7/4, both correct. And as well, you can see it here in the graph. These 2 points are now really important for our average rate of change. What we're going to do is we're going to calculate these, and you'll see here what we do is changes in y over the change in x. What we do, the official function is like this. You got x2, which is the second point, the function with that value minus the function with the first value. And if we look at the two things that we calculated here above, -4, f of -4 would be the first one, x1, and f of -1 is the second x, right? Because that's the end of our interval. All right, plug it in, and we'll find the average rate of change between these 2 points is 0.75. And it turns out that this 0.75 actually is exactly the same as the slope through these 2 points. And that's the idea of an average rate of change. So we're trying to see how much does the function change in between 2 points, even though it's not a linear function. So we're finding 2 points that are given in an interval. All right. Now we're going to look at a little bit different function, and we're going to look at this function to be exact. And so we can get that totally in the window. X squared plus 4x minus 2. And this is then the function that we're looking at. All right, you see here, and I've already plugged a couple of points here, and these are important for the intervals that we're going to do. All right, you can do, for every function that you can find, you can do a million different intervals. And even with the points that just graphed here on the left, we can do a lot of intervals. But we're just going to look at these intervals. All right, so we're going to look at -5 to -3, -4 to -2, -3 to -1, and -2 to 0. The other ones are examples of other intervals. A lot of times it's really a big help if you just put in the table. I mean, you have your graphing calculator, just plug in the formula and just let your calculator do the actual work of making the table, because then you have your coordinates for every point and you can calculate whichever 2 points you look at and then go from there. First, we're going to look at the interval -5 to -3. So what we want is, if we look at our graph, we want to see from here x is -5 to x is -3, what is the slope of this line? What is the average change in that line between those 2 points, in that interval of -5 to -3? So what we need to do is we need to look at our table, and we look at our x value -3, because that's our second point and comes first in our equation. So we got on the y values, we'll have -5 minus the value of the other point. So -5 minus 3, that's our other point, over the change in x's, which will be -3 minus a -5, right, which is +2. So what we get is we get -8/2, which actually is -4. And if you look correctly, this line has a slope of -4. And that's what we're doing. Average rate of change is the same as the slope between these 2 points. And these 2 points are found by a function. In this case, function of x squared plus 4x minus 2. Okay, let's look at the other intervals, the second interval. What we're doing now is exactly the same as before. And we get -4 and -2 as our x values. And we start at -2. -2 is our end of our interval. So that one comes first. So we'll get -6 minus a -2. Right? Remember that subtracting a negative actually makes it adding a number. So if we got -4 to -2, because that's our interval, we got -6 minus a -2. And that is a -4/2, because the change in x is 2, which equals to a -2. And if we look at our graph, this line between those 2 points is actually has a slope of -2. And you see quite a bit of a change between the first one and the second one, because that's what slope does. All right, the further the slope, the number of the slope is away from 0, the steeper the line. Alright, so in the first one it was -4, now it's -2, so it's a little less steep. Alright, then we're going to look at the next one, and we go from -3 to -1. So we get -3, our y value is -5, and -1, hey, also has a y value of -5, which actually means if we're going to calculate, we can all calculate, but we might have already seen it. It actually does not change much, because from y to y, it's exactly the same, meaning that our slope will be equal to 0. Our average rate of change is exactly 0 in this case, a horizontal line, which actually has a function of y is equal to -5. All right, I'm going to put in the last one that we're going to calculate right here, and that is -2 to 0. And we'll see a slope that is +2 in this case. And you'll see in the function that it goes back up. So what we're doing, if I put in all of these lines that we've calculated right now, we looked at average rate of change of several different points. Put this in as well. And even though it's not a linear graph, different kind of functions, we have looked at all the average rate of change within different intervals. I hope you guys understand a little bit of what I mean, and if not, we'll talk about it more in class. Thank you, and see you guys tomorrow.